Hello, welcome to section Neural Networks. In the last section, we had everything set up for this course. In this section, we'll concentrate on the fundamental concepts like what the classification and clustering is, the softmax activation function, multilinear regression, and logistic regression. But this should not lead you to think that we are going all through theoretical. Instead, we'll be doing all of them applied on Java, such as we are going to show you that how you can load the data, build a classification model, and evaluate the model. Now, we move on to the first video of this section that explains the classification and clustering. By the end of this video, you'll know about what the classification and clustering is, also know how to build a model by taking CSV file as an input to the classification algorithm that you'll learn in this video, and make predictions using another CSV file and validate these predictions using several metrics. In this video, we are going to take a look at the definition of the concepts, and once we learn them, we are going to apply them using Deep Learning 4G framework right away. Therefore, application part consists of: first, learn how to load data; second, learn how to pre-process it; and finally, build a classification model and validate the model. Classification is taking an input X and giving it a label like Y. The typical approach is taking the training set that has already been labeled, train the classification model using this set, and when it is done, use it for classification, or in the other words, prediction. It's one of the fundamental concepts of learning algorithms. Deep learning have high accuracy in terms of classification tasks in almost every prediction task. Classification is taking a part in such fields: object recognition or face recognition in images or videos, voice recognition, text recognition, fraud detection in insurance companies, and customer satisfaction analysis. In this video, we are going to show you that a basic classification task by taking CSV file, which is already labeled data. On the other hand, clustering is a kind of grouping variables without using labels. Since the real world have most of the data as unlabeled, this becomes a very important task. We can think of it as a way of separating the data with some boundaries. And to identify the boundaries is the responsibility of clustering algorithms. In deep learning, we can extract hidden features in the data, or in the other words, figure out the representation of the raw data using stack of deep layers, and finally apply classification algorithm to identify the object in the image or any pattern in the data, like spike in the time series data. You can see clustering in following cases like grouping documents, text sounds or products, detecting anomalies in the data. In Deep Learning 4G framework, you can use several clustering algorithms. K-means algorithm is maybe the most popular one. Also, you can use autoencoders to extract features or compress the data for principal component analysis. Let's see an example. Here I'm going to build a classification algorithm by taking the input from the train and test CSV file. It's good practice to normalize the data before feeding it into the neural net. In this example, I'm going to use max-min scaler, which will scale the data between 0 and 1. First, create CSV record reader and specify separator of the CSV file. Also, specify how many lines to skip. And of course, we need to give it a source file to read from by supplying file split instance. Second, we need to create a record reader dataset iterator which takes CSV record reader as an input, batch size, number of distinct labels, label column index, and Boolean value that indicates if this is a regression problem or classification problem. When we are done with creating record readers, now we can set the preprocessor by calling setPreprocessor method. Here, notice that we build a normalizer model using training data. And we'll use this directly for the test data as well. Even though test data may vary in the real time and mislead our model, using the training data for building normalizer is the best approximation we can have. And that's it. Our data is ready to feed into. Let's look at our data. In our data, we have 6 columns. First 5 is features and the last one is target. The target consists of 2 categories. Right here, we specify the label index as 6th column. And it consists of 2 categories, 0 and 1. Now it's time to create a classification model. Here I'm going to create a multi-layer network with one hidden layer. This is the simplest nonlinear model we can have. Here I'm using optimization algorithm as a stochastic gradient descent. This one is famous. You can see it like everywhere. And my dropout ratio is 0.5. This is to prevent overfitting. I'll tell you all about that later on. And notice that my loss function is negative log likelihood because I'm building a classification algorithm. So that's my model. Let's train this model. To train it, we are going to write a for loop. At each iteration, we are going to fit the model and evaluate the model after fitting it. Let's run it. At first iteration, we have accuracy of 0.33. At the end of it, we have accuracy of 0.46. Our model learned little bit. And for now, that's it. In this video, we have covered the concepts of classification and clustering. Also learned how to build a classification model. Clustering could also be achieved using k-means algorithm in Deep Learning 4G framework. But we are not going to cover k-means in this course. However, in the next videos, we are going to show you autoencoders, and they are unsupervised learning techniques. So stay tuned if you want to know about them. In the next video, we are going to introduce you one of the building blocks of classification in neural networks, which is activation function, in specific softmax function.